Hello everyone, I Dr. Sanjay Upreti welcome you to the channel Electrical Science by Dr. Sanjay Upreti. So in today's video, we are going to discuss a problem of a Thevenin equivalent. So this problem was asked in the midterm examinations of a electrical science paper conducted by the IP University. So in this problem, there are the three number of the sources are there. So two voltage sources, 130 volt voltage source, 10 volt voltage source, and the 38 ampere current source. So to find the Thevenin, so we have to find out the Thevenin resistance and the Thevenin voltage. So first we will find out the Thevenin resistance. So to determine the Thevenin resistance, what we will do that we will make this voltage source as a ineffective and the current source as current source ineffective. So to make them ineffective, so we will I will make this 130 voltage source as a voltage source by short circuiting the voltage sources and the open circuiting the current sources. So resulting circuit will be like this one. So in this one, the voltage sources are short circuited and current sources open circuited. So this is the resistance between the point A and B is will be equal to the RTH. So RAB will be equal to, so if we find out the RAB, so RAB is the that is the 6 ohm resistance, and this 4 ohm and 2 ohm resistance are connected in a series, and this connected in parallel with the 6 ohm. So it can be written here as a 6 ohm resistance in parallel with 4 plus 2 ohm resistance, right? So it is equal to the 6 ohm resistance in parallel with the 6 ohm. So if you calculate this one by so that is will be equal to the 6 by 6 but divided by 6 plus 6, and that is equal to the 36 divided by 12, and it is equal to 3 ohm. So our value of the RTH here is the 3 ohm. That is very easy one. Now the second part is the determination of the Thevenin voltage or the VTH. So in this method, so for finding the Thevenin voltage, so we can employ the multiple methods here. So first method we will be employing here will be the first method. So we will be applying the KCL here. Okay. By using the KCL, we will find out the Thevenin equivalent. So Thevenin equivalent, it is the Thevenin equivalent voltage. That is voltage between the point A and B. All the sources are connected. So by using the KCL, so we can see here in this at this point here, right? So let us say potential here is the VA, right? Or let us say this point B, it is the reference node. The voltage here is the 0. VB, this is connected to VB. So this is the reference one, and this is the grounded. So here the VB is equal to 0, right? So to find the KVL, so let us say there are the three currents are flowing. This current is I1, this current is I2 flowing here, right? Similarly, 38 ampere current is coming here. So 38 ampere, let us write this one. So in applying the KCL at the node A, so it will be equal to the I1 plus I2 or minus 38 is equal to 0. Okay. So we have assumed I1 as a leaving current, I2 is leaving current, and 38 is entering current, entering at the node. So I1 can be written here as the VA, that potential here is the VA, or this voltage 10 volt is supporting this VA, so it will become 1 VA plus 10 or minus 130 volt. So minus 130, or total resistance between this branch is equal to 2 plus 4, that is equal to 6. And that is plus second I2 is the VA divided by 6, or let us take this 38 into the right hand side, so it will become 38. So multiply total equation by the 6, so it will give you the VA minus 120 or plus VA is equal to 38 multiplied by 6. Okay. So this equation will become 2VA minus 120 is equal to when you multiply 6 by 38, so it will become 228, right? So it will give you the 2VA is equal to 228 plus 120, and it is equal to the 348. So it will give you the VA is equal to 348 divided by 2, and it is equal to the 174 volt. So right, that is, so VTH here it is coming from the by the KCL method, it is coming here is the 174 volt. I hope this is very it was a very easy method. Very easily we can find out the value of the VTH. But let us try the another method also. So for trying the another method, so we can apply the KVL here, right? In this mesh we can apply the KVL. So let us try to find out the VTH by the by this KVL method or mesh analysis. So first let me erase this all these things. So let me erase this one. So okay. Let me erase all this one, this thing also. Okay. So so let us say the current flowing here in this one is the current is flowing here as a, this is flowing here as a I, right? So write the equation here, KVL equation, voltage equation in this mesh. So it will be equal to the writing this equation will give you the, that is 130 that is 130 volt, right? Let us write the potential rise as a plus, then this is a 2I, this is a 4I, so it will become minus 6I. Similarly, this voltage is opposite, so it will come as a minus here. Okay, because here is, this is the potential rise, this is a potential drop, so it will come as a minus, or then again there is a potential drop, so that is minus 6 multiplied by, or then the total current is in 6 ohm resistance is the I current is flowing, because in this mesh, and 38 ampere current is coming from this current source, so it will become the I plus 38. So it will become, so it should be equal to the 0. So that is 130 minus 6I minus 10. So minus 10, 130 minus 10, it will become 120. So let me put here the 120 here. Let me put here 120. 120 or minus 6. Let me use the color blue also here. So minus 6I, or minus, it will become minus 6I, or when you 6 multiplied by 6 multiplied by 38, so it will become minus 228. It is equal to 0. So 6 and 6, it become 12I, or when you subtract 120 from 228, so it will give you the 108. So it will give you basically the 12I. Simplifying this one, it will give you the minus of 108. So it will give you the I will be equal, will give you the minus 9 ampere, right? Minus 9 ampere. Minus 9 ampere current is flowing here. This value of the I is equal to minus 9 ampere. So total current in the 6 ohm resistance, total current in 6 ohm resistance will become the I plus 38. I current flowing because of this these two voltage sources, and 38 ampere current is flowing because of this 38 ampere. So it will become minus 9 plus 38. So it will become 29 amperes. So total current here is the current flowing here is the 29 ampere. So voltage drop across this 6 ohm resistance is also voltage drop across this VAB. So VAB will be equal to the V6 ohm, or that is 29 multiplied by 6. And when you multiply by 29 by 6, so it will 6 multiplied by 9, it is 54, and 6 multiplied by 2, 12, 12 plus 5, it is 17, 174. So it is also 174 was answer coming from the KCL node, KCL, and from the KVL it is also coming as a 174. Right? So we can use the third method also. So for applying the third method, we will have to change this current source into the voltage source. So I have already made this one here. So this 6 ohm, this current source which was here, now it is replaced by this voltage source here. So value of the voltage source will be equal to the 6 multiplied by 38, and it is equal to 228 volt. So it will be equal to the 228 volt source, right? So this 220 volt source, and it will be connected like this one, because it will I have connected it here in this manner, because it will give you the current here in this 38 ampere current in this direction, right? Or earlier you can see here, sorry, in this one the 38 ampere current is flowing in the downward direction. So in this one also 38 ampere is flowing in this downward direction also. So that is the equivalent circuit. That is equivalent circuit by replacing the current source. Here you can apply the mesh analysis over here. Let us say this current flowing is here the I, right? So I, if you multiply, if you apply this mesh analysis here, so it will give you the that will give you the 130 minus 2 and 2, that will be give you the 6I, or then it is minus 10, or plus, that is 228, right? Plus 228, that will give you the 228. It will give you 228 voltage here, and then it is a now the plus minus 6I, that is equal to 0. So let us solve this one. So 6I and 6I will become the 12, right? Or that will give that will give you the 130, or 130 minus 10, it is equal to 120. 120 plus 228 minus 12I is equal to 0. So if you add these two, this addition of this will give you the 348. 348 minus 12I is equal to 0. So 12I will be equal to the 348 divided by 12. So it will give you the current, it will be give you the 29 amperes. I will be equal to the 29 amperes. So V6 ohm will be equal to the 6 multiplied by 29, or it will give you the 172 volt, 174 volt, sorry. So from all the three methods, this answer is coming as a 138 volt. The question in this question, the most noticeable thing is that I have connected this 220 volt source over here. So it can be connected like this one. So this voltage source can be connected like this one also. Yeah, that can be connected like this one here, right? So you can make a mistake by connecting over here, that is minus plus. So it should not be connected when you are connecting this voltage sources. So it should not be connected like this one, because in this original circuit you can see here the 6 ohm resistance is connected directly parallel to these two terminals, these two load terminals. So that is why in this one, if you connect this voltage source here, then the 6 ohm will no longer will be connected in parallel to the AB. So this voltage sources, it should not be connected like here, it should be connected like this one, then it will give you the right answer. So finally we have calculated the Thevenin volt equivalent. In Thevenin equivalent, it is voltage is 174 volt and RTS value is coming as a 3 ohm. I hope you will like this explanation and of the Thevenin equivalent by the three methods. If you like this video, please hit the like button and subscribe the channel. Thank you.